Okay, starting with problem number three. Again, I know it's a volume problem. We're going to take a region and we're going to rotate that region about an axis. So the first thing to do is just kind of visualize what they're telling me over here. And it doesn't look that bad to me. I definitely see this over here. This is a parabola. That's checked off. That was pretty easy to do. And then that 2x plus 3, what does that look like? I'm going to say, I got to go up 3 units and I got a slope of 2. So maybe something like this over here. My problem is I don't know what these points of intersection are, but I do know there's a region there. All right? So what I'm going to do over here, I'm going to try to find out what those points of intersection is. How do I do that? Set x squared equal to 2x plus 3. Again, what are we doing? We're setting this equal to that, and I wonder what x value would do that for me. So let's put this down. X squared minus 2x minus 3 equals 0. X and x. 3 and 1 minus plus. So I'm going to say this point over here, minus 1, comma. We'll talk about that later. And this one over here is 3 comma something. So what's the minus 1 going to give you? It's going to give you just 1. How do I do that? I plug it into this equation because it's easy. You could also plug it into there. You're still going to get 1. Now, if I put 3 in, I get 9. Now, whether I plug it in here or plug it in there, I'm still going to get 9. So I'm pretty comfortable that I know the points of intersection and what region they're dealing with now. I'm going to start to erase, by the way, the extraneous stuff over here. I'm kind of done with that. Again, some students actually do have. I do not recommend that. I recommend writing things down and communicating on paper. All right? Okay, so what are they? It says find the volume of the solid obtained by rotating the region. I see the region of these two curves about the x-axis. All right? So what I got to do is I got to visualize what that looks like. And for me, it's always going to be a rectangle. Looks like this over here. I got troubles, though. And the troubles is it's really going to be a disc with a hole in it. So I looked at that. I'm going to get a disc, but there's going to be a hole in it. All right? So what I like to do is I like to just do the big disc. Don't even think about the hole. Let me talk about that for a second. Do the big disc. Don't even worry about it. And then subtract away the small disc. That's the hole, by the way. Let's put it down. So what do? The differential is dx. I'm going to do the big disc. This is big. This is the hole. That's what we're drilling out of it. Where do I start? At minus 1. Where do I stop? At 3. We're going along the axis. So what do I get? I get pi r squared. What's the r? It's the line. That's all it is. Let's write that down. 2x plus 3. We'll do that later. Minus, I'm going to take away that small disk. What's that going to be? Pi r squared dx. What's this small disk? Its radius. It's going to be this guy over here, which is x squared. All right? Now, by the way, we're at a milestone here, and I want to point out, once you're at a milestone, see if you got it. See if you have this over here. It might be written a little bit differently, but I'm going to say minus 1 to 3. I did take these and wrote one integration down. We'll do it in a moment, by the way. I do see that, and I do see them taking that away. All right? So I'm going to say I'm there. I'm right there. What I'm going to do is I'm going to start to do it now. All right? So what do you do over here? Well, it's minus 1 to 3. I'm going to take these two integrations and pull them together now. I'm going to pull the pi out. I'm going to square this part over here. What do you get? 4x squared plus 6x and 6 is 12x plus 9. Remember, we pulled the pi out. And what am I left off with? Minus x to the 4th dx. Can I integrate that guy? I can integrate that guy. And let's put that down. By the way, I know it's going to look a little different than the work down here. Don't worry about that. All right? What do you get? Pi. And then, 4x squared is going to be 4x cubed over 3 plus 12x squared over 2, so 6x squared, plus 9x minus x5 over 5. The limits of integration go from minus 1 to 3. Yeah, I know it's problematic. I still want to do the arithmetic. If it's taken you an hour to do this arithmetic, though, you need to cut your losses, and I really mean that. It is not worth an hour, all right? Let's write this down, pi. You're going to get 4 times 3 cubed, but one of the 3's canceled off, so really what you get is 4 times 3 squared. 3 squared is 9, so you get 36. Again, 3 squared is 9, 6 times 9 is 54. Plus. 9 times 3 is 27. What do you got now? This is going to get tough. We get 3 to the 5th power, all right? 3 times 3 is 9, times 3 is 27, times 3 is 81. I'm at the 4th power now. 3 times 81, 243 over 5. Yep, I know that's painful for a lot of students. We're trying to encourage you to work on this, though. What do you get now? Oh, boy. You get minus 4/3. What do you get next? Plus 6, minus 9, and then plus 1/5. All right? I got to go through it, every single step of it. All right? So the way I'm going to do that, I'm going to look at things that are easy for me to do. All right? So I'm going to say 54 and 36. Well, that's 60, 90, 110, 117. All right, we're going to write that down now. Let me repeat. 36, 54, 90. 90 and 20, 110. And a 7, 117. Minus 243 over 5. Let's keep going. Minus pi. I'm going to do things that are easy for me. 6 minus 9 is minus 3. That's easy. Minus 4/3. I'm going to do this now. It's thirds, right? So 3 times 3 is minus 9, minus 4, and that's going to be minus 13/3. Wow. All right, so I got those 3, and then I got the plus 1/5. All right, more work to do. Yeah, it's getting a little bit simpler. So what do you get? You get pi. I'm going to do this, 117. I'm going to do this and this. I'm going to combine those together. What does it give me? Minus 2, 4, 4 over 5. Then what do you get? Minus 13/3. Boy. Oh, I'm sorry, plus 13/3. I'll make a mistake. We got a key to look at too. Pi. Column denominator 15. Boy, that looks tough. 117 times 15. Well, let's see. That's going to be 1170. 5 times 7 is 35. 5 times 1 is 5. That's 8. 5. You get 1. Let me do this one. Sorry about that. Maybe I shouldn't have done that. I mean, you could have, but it's probably not a good idea to do in that direction. 5, 15, 7, 1755. Minus, I got to do 3 times 244. 12, 12, 13, 6, 7, 732. Plus, I got to do 5 times 13, 50, and 15, 65. All right, again, I know it's a lot of work. It's too much work for me. We're encouraging it, by the way. 1755 plus 65. That's 10. You're going to get 12, 8, 18, 20. And then you're going to take away minus 1732. All right, I'm going to borrow from this. This becomes 10. I should say not 10. I'm going too fast, by the way. I'll put 1 down. It will be a 10 later, by the way. This is 10. That's 8. Let's see, 3 from 1. I think I might have made a mistake somewhere. This is 7. This will be 10. 7, 0, 1078. And they got 1088. I wonder if I made a mistake. And I don't know. Boy, if that was a multiple choice exam, I'd be flummoxed at this point. I say I got 1078. I'm looking at a bunch of answers over there. And let's see if I did something wrong. I'm looking at it. Again, it's not a multiple choice exam. I see the key there. I wonder if the key is wrong. I might have made a mistake. Who knows? Let's see, 117 times 15, 117. Oh, I got that part. Let's see, 585. I'm checking this over here now. 5 times 7 is 35. 5, 8, I got that. 5, that's 5. 8 and 7 is 15. 7, I get 1755. That's not bad. I think I did all right with that. And then let's see if I did the 3 times 244. And that's 600, 720, 732. And 5 times 13, 65. 65 and 1755, I did that right. 5 plus 5 is 10. 12. 8, 18, yeah, I see that. And 732. Oh, I made a mistake. I see it now. Let me erase this over here. I'm glad I'm seeing the mistakes, by the way. 18, 20, minus 732. Okay. 2 from, this is 1. 2 from 10 is 8. Did I say 732? Let's get a careful look again. 2 from 10. This is 7. $18.20. I see it now. I'm doing arithmetic the way I shouldn't be doing arithmetic, and I just realized it. Let me write that down again. I made a really egregious error, by the way, and I'm glad I'm making errors because it really reflects that everyone can make an error, by the way. Now, when I look at this, I would not do longhand arithmetic. I would definitely say 1,088. Let me go through that again. This becomes a 1. I made a mistake, by the way. This becomes a 10. That's 8. I borrow from this, becomes a 7. That's what I did not do, by the way. So this becomes 11. Sorry about that. 3 from 11 is 8. 7 from 7 is 0. Yeah, so what do you get over here? Pi. There's no mistake in the answer key. 1,088 over 15 is the correct answer. All right? Made a small mistake there. What was a mistake? Going back to what I learned in grade school, which is probably not the best way of doing arithmetic, but I did make a mistake, and really just, I guess, really just sloppiness. All right, I knew the answer was correct in a second pass through it. All right, thank you.